Okay, we're looking at your notes. An object moving along a curve has this position. They give you dx dt. Guys, make sure you understand that this is x prime. Okay, because some students look at this and they think that this is x. Okay, this is not x, this is x prime. This is y prime, and then at time 2, the object is in position 1, 4. Find the acceleration vector for the particle at t equals 2. Find the acceleration vector when t is equal to 2. Guys, let's think about our goal, okay? What is our notation going to look like when we're done with the acceleration vector? What are we looking for? X double prime, y double prime, okay? And I can't tell you how many students will go take this number up here and take the derivative twice. Guys, if you have x prime, do you take it twice to get x double prime? No, what do you do to get x double prime? Just once. So what I want to do, if this makes any sense, I want to take the derivative of this and plug in 2. You agree with that? I want to take the derivative of this and plug in 2. Okay, if I take the derivative of this and plug in 2, don't you agree that that's just a math 8 in my calculator? Right? So it's a lot faster on your test, okay? It's a lot faster on your test if you realize that you can just go to your calculator. Okay, so pull your calculators out, guys. Okay, make sure you're not about to get every single trig function wrong by having degrees in there. Okay, make sure you're in radian mode, and if you reset your calculator, you'll be in radian mode. Okay, and all I want to do is right here on my y equals, my y1, put in the dx dt. So I'm going to put in sine t cubed right here, sine x raised to the 3rd power. Okay. And guys, those of you guys who don't work along with me, hopefully that you can just absorb without doing it. But you've got to work. You've got to do this yourself, or you can't learn. All right. And then dy dt is going to be cosine x squared. So cosine x squared. Oops, that's not x squared. What happens if I hit clear? Oh, okay. Cosine x squared. All right. Okay, I've got my dy dt, dx dt, and my dy dt. Let me go to my home screen, which is second quit, and I'm going to do a math 8 and plug in 2, right? So for the x dx dt, I'll do a math 8, okay? That's going to be x. Right here, this is going to be my y1, because let me just label this. I did this as y1, and this is y2. So this is going to be my y1, which I learned a few weeks ago that I can just hit alpha trace, and then pick y1, which is kind of cool. And then my x that I'm going to plug in is 2. So remember, if your calculator, if you don't have this t equals 2, your calculator can't do it. Okay. Well, this calculator can't do it. Okay. And so if you have t equals 2, you can just put it right into your calculator. Don't forget to pray. Hit enter, and what we have is negative 1.746. Okay, and that is x prime at 2. All right. If I want y prime at 2, then I'm going to do the same thing, but with my y2 equation. So that's going to be, again, a math 8, because we're doing derivatives. Okay, this will be x. Punch in y2 here. So that's going to be alpha trace. Choose y2 this time. Okay, go to my x. I'm still going to plug in 2. Pray, hit enter, and I get 3.027. And can you get any easier than that? All right, that's your acceleration vector. Any questions on that? All right, let's look at letter B. Write the equation of a tangent line when time is 2. What do I need when it says write the equation of a tangent line? Point and slope. What is the format of my point going to be? I want a point, x, y. So I'm just looking for some coordinate here, x, y. What is the format of my slope going to be? When I say derivative, you say slope of a tangent line. So you agree this is the slope of a tangent line? So what do you really want here? dy dx. Guys, even though you have t's here, okay, your slope, remember, it's still just some curve. It's still some curve on an xy plane, okay? And the derivative at any point is still dy dx. So we're still looking at dy dx's. And so let's look at this. Do I have a point? Is there an xy at time 2? Do I know xy at times 2? Oh, look at that. By golly gee whiz. It's right there. So let's just go ahead and write that in. So everybody see how that works. All right. I also need a slope at time 2. Okay. How do I get a slope at time 2? Yeah, you need your formula. Do you remember your formula for dy over dx? dy over dt over dx dt, okay? dy dt over dx dt, and actually that is this function here. So it's going to be sine of t cubed over dx dt. Oh, no, that's totally wrong. Sorry. That's actually a very common mistake that I make and that you make. And like I always say, it doesn't matter when I make the mistake because I don't take the test, okay? But you guys can't make it. You're not allowed to make mistakes. I am, okay? All right, and so this is a great answer. It's just that it's got to be a number. So how do I change this to a number? Do I have a time to plug in? Yeah, it's 2. So this will be cosine 4 over sine 8, okay? And what is cosine 4? 4 is the angle. So at angle 4 radians, what is my cosine value? Okay, you can just stop right there. You guys good with that? If you have a calculator, you can put it in and change it to decimals if that makes you happy. But honestly, you could stop right there just because it's not on the unit circle. And that is the answer. It's just kind of like when you get ln 5. You know, you want to put it in your calculator, but you don't really have to. ln 5 is a number. All right, so let's go ahead and put this into an equation. The equation is y minus y is equal to the slope times x minus x. You guys comfortable with that? Okay, and again, if you want to, you could change this into a decimal. Make sure if you do that you go 3 decimal places, and make sure you punch in the right numbers. Otherwise, you don't really have to change it to a decimal. All right, letter C. Find the speed. What's the equation, guys? Okay, the square root of dx dt squared plus dy dt squared. And guys, if you don't know your formulas, you just need to go home, sit down in a dark room. Okay, I prefer closets, but it doesn't have to be a closet because then you have to come out of the closet. Okay, but sit down, turn on the light, figure it out. Okay, and see if you can memorize all those formulas. Because if you don't have formulas memorized, calculus is super hard. Okay, all right. What students do here is they'll write the speed and then they'll be like, oh, I got to make it a calculus problem. Okay, guys, if you integrate speed, what do you get? Total distance or arc length. Okay, are we trying to find arc length here? No, so please do not integrate this. This is a formula for speed. All right, so I just need dx dt, which isn't too hard. Oh, it's right there. It's right there, okay. Actually, I would say by golly gee, but would you look at that works too. Okay, guys, do I take the derivative of this? No, guys, do you see that this actually matches? It's dx dt. So you would just carry it right here into the parentheses squared plus dy dt cosine t squared squared. Okay. It really is just kind of a matching game for some of these problems. All right. And then you want the time at 2. So what you're going to do is change this to an 8, right? Change this to a 4, and then punch this into my calculator. Okay, so I'm going to have sine of 8. Okay, make sure I'm in radian mode. I'm going to square that. Then I'm going to add that with cosine of 4. So let's do cosine of 4. Okay, I'm going to square that. Enter. Don't forget to square root your answer. So second square root, second answer, enter. And can you give me a check on this one? 1.186. Did you guys get that? Okay, so that is your speed at time 2. Pretty straightforward, right? You guys okay with that? You really just need to know the formula. All right, let's look at your next question here. You're going to find the position at time equals 1. Okay, let's think about my goal. I need a goal. Okay, what am I trying to find in calculus talk? The position, x, comma, y. And in particular, if I'm saying time 1, then really what? x1, comma, y1. Okay, everyone agrees on that. I'm trying to find x1, comma, y1. All right, let's see what I'm given here. I'm given the position at time 2. So do you agree that this right here is actually, in calculus talk, that's x2, and this one right here is actually y2. Okay, so I'm trying to get all my calculus talk out here. This right here is really x prime. This right here is really y prime. All right, so what I'm doing is I'm moving from x prime, y prime, and I want to get xy, you know you're going to have to do what? Integrate, okay? So what I want to show you is if you use the first fundamental theorem of calculus, this will work out great. If you don't, so let me just not use it. Let me say, you know, in the old days, I would say, if I want to move from dx dt to x, I need to solve this dx dt. So first you separate, then you integrate. And on the left side, it'll be great because it'll be x plus c. And I'll move my c to the right. But on the right side, it won't be great. Because if this is your u, okay, your du dt is never going to cancel out. Okay, so your dt would be du over 3t squared. If I rewrite this, this would be sine u times du over 3t squared. You'll never be able to get that out, okay? So that's why you don't want to use this separate thing, because you have to be able to integrate by hand. So you actually are forced now to use the first fundamental theorem of calculus, okay? That's not really a force. I know you guys like it anyway, okay? So this will be x prime, okay? I'm going to put dt there because I know it's a dt problem. And this will be x parentheses minus x parentheses. Okay, it's just the skeleton of the first fundamental theorem of calculus, right? If this is a t, then these limits have to be t. What two t's do I have here? 1 and 2. Okay, 1 here and 2 here. All right, so if this is 1 and 2, this must be 2 and 1. These would autofill, if that makes sense. Okay, then you just put in your equation here. X prime, according to this problem, is sine t cubed dt. X2 is 1. I've been given that. X1 is what I'm trying to find. Okay, and this looks super hard, but really x1 is just equal to, if I move that over here, 1 minus the integral of 1 to 2 sine of t cubed dt, right? And this is just a calculator problem. Okay, so I can go into the calculator, okay, and do you want to just do 1 minus? We can do 1 minus math 9, okay, from 1 to 2 sine t cubed. I think you guys have figured it out by now, but I use x instead of t's. I'm kind of tricky that way. My calculator doesn't know any better. It lets me do it. And so my calculator doesn't know I'm solving for t's, but I'm just kind of tricky that way. Okay, so I still get the same answer. Pray, hit enter, and x1 is equal to 0.782. Did you guys get the same? Yes. Okay, so that's my x1. But I don't want to just find x1. What do I also want to find? y1. Okay, so I've got my x1. Let's go find my y1. And you guys go ahead and set that up. Well, I do a little bit of organizing here. Okay. Is that math? It can't be. That would never happen in math. Okay. Y. Okay. They're probably writing because they have to have a shirt that's the same as AB. Okay. So this is your Y side. This is T. What are my T's here? Still 1 and 2, right? So actually this looks exactly the same. It's just that all my X's are now Y's. Okay. So my Y prime now is going to be cosine T squared dt is equal to y2, which I know is 4, minus y1, which I'm looking for. So therefore, if I solve for y1, that's equal to 4 minus this integral from 1 to 2 cosine t squared dt. Okay, this is not something you can do without a calculator. So I'm going to get my handy dandy calculator out. Okay, and I'm going to say 4 minus the integral of, so that's going to be math 9, from 1 to 2. This will be cosine t squared dx. Pray, hit enter, and I'm getting 4.443. Can I get a second on that? Yes, okay. So guys, this answer is 4.443, and that is your new position. Pretty easy. Do you feel comfortable with that? Okay, it should come pretty easy for you. Students do have trouble with this problem. I think they just forget how to do it. Okay, but it's not bad because after this we go into polar, and then when you go to polar, you're just so messed up that you forget how to do the easy stuff. So, okay, so we're good with this. Let's go ahead and look at your homework tonight. You have Vectors 1 worksheet number 7. You guys pull that out with me, please. Number 7 on your Vectors 1 worksheet. So we're looking at your homework for tonight. So your homework for tonight is finishing up this Vectors 1 worksheet, okay? And then remember again, guys, you'll need your calculator for problems 10 and 13C. And then your Vectors 2 worksheet, Vectors 2. This should not be bad at all. You're just going to do number 1 through 6 on Vectors 2. Okay? And then we'll come back on Monday and talk about what you need to do. All right, but right now I want to look at number 7 on your Vectors 1 worksheet. Okay, that problem, you have x, y is equal to 10. Tell me if I'm doing the wrong problem. I think, is it dx dt is equal to 3 or dy dt? dy dt, okay. dy dt is equal to 3. And then they tell you something else. X is 2. Okay. And they're asking you to find dx dt. Okay. All right, let's think about this. If you look at this problem, you've got x and y's is equal to 10, and you're trying to get this into dt form. I mean, how do I do that? How do I, if I have an equation, how do I even move that into a dt form? Find dy dx, okay. So if I found dy dx, could I find dy dx? How? Take the derivative of this with respect to x. There's an easy way, but no, that's okay. You're going to do the ddx. Do you see any other easier way to take the derivative of this with respect to x? Like, that's okay. You're doing implicit differentiation. Look, let me just tell you, but you're not going to think of this on your test. Actually, I would put a star by this question. I'll tell you how to do it easily, but you're not going to think of this on your test. This is y equals 10 over x, right? So that would be way easier to take the derivative than if you try to do implicit. I don't know if y'all saw that. Okay, I'm going to suggest another way, because actually I think they're going the right direction. But I'm going to suggest another way. Let's think about this again. Think about this as a related rates problem. Remember the related rates days? If you have an equation, and you have all these rates, okay? How do you get this into a rate? How do you get this into a rate? Remember what we would do before we did the moment in time? What would you do to it? Take the DDT of it. Do you remember this in the related rates days? Okay. This would be the DDT of both sides. I mean, am I allowed to do the DDT of both sides? Sure. Okay. So what's the derivative, DDT of xy? Now, this is implicit differentiation. So it's the derivative, and no matter what on this problem, you're not going to avoid implicit differentiation. Oh, except if you had done it the way they're saying. But the way they're saying is it as intuitive. So let's look at it this way. If we did the DDT on this side, what's the derivative of xy? It's going to be the derivative of the first times the second plus the derivative of the second times the first. What's the derivative of 10? And please don't say 1. 0. Okay. This is really nice, okay? Because look, now I've got this equation that has dy dt in it. It has x in it. It has dx dt in it. It does. Like right here, this is dx dt. Okay, wait a minute. I need to know y. Do I know y? You can find y. Does anybody see how you can find y? You plug it in. You know xy equals 10. You know x is 2. Can you tell me what y is? Y is 5. So you already know y is 5 because xy equals 10 and x equals 2. So therefore y is 5. Okay? So knowing all of this, this is pretty easy to do. Are you guys good with that? Please put a star by it. I can't tell you how many students miss this on the test. It's because you kind of don't see that it's kind of a related rates problem, basically. Okay? But you know how to do this. But if you don't approach it right, it'll be a big mess. I want to also, David, do you want me to do it the way you guys are saying, or are you guys good with this way? I don't see an element, but okay, I can work with you later on that so it doesn't confuse everyone. So that's number 7. Taking note is also like kind of a tough problem on this one. Number 10. Can we do number 10? Are you guys okay with that? Okay, let's look at number 10. Okay, we're looking at vectors 1 still. Okay, now what you have is x of t is equal to 5t plus 3 sine t. You've got yt is equal to 8 minus t, 1 minus cosine t. You want the velocity vector when x is 25. Okay, so we're looking for the velocity vector when x is 25. All right, let's talk about this. All right, what's my goal? What's my calculus? Let's do calculus talk. What does velocity vector look like? That's what I want. X prime or x double prime? X prime, y prime. You agree with that? Okay. When x is 25. So what I want to do is take this derivative, okay, and plug in x is 25, and take this derivative and plug in x is 25. That makes no sense. Okay, let's just think about it again. Let me take this derivative. If I take x prime, okay, let's take the derivative of that. Isn't that 5 plus 3 cosine t? You agree with that? Okay. What's y prime going to be? Product rule. No, not a terrible product rule, though. Derivative of the first times the second plus derivative of the second, which I think is a negative, okay, times the first. Okay? Ugly, but we'll keep it. Okay? All right. So what I want to do is plug in the right t. Okay? And then I'll get the answer. Everybody good with that? Okay, so I want to plug in the right t. So what t do I plug in? It's when what? What t is when x is 25. So how do I find out t when x is 25? You set x equal to 25, right? So what I'm going to do is I'm going to come up here and say, okay, when x is 25, what is my t? Okay, and I'm going to try to pull out my t here. As I try to pull that out, I have either a hernia or a conniption fit. I mean, something bad is going to happen, okay, because there's no way to pull out that t. So how do you solve for t when you can't solve for t? Your handy-dandy calculator. Okay, so let's go down to our calculator. And so what you would do is you just say y1 equals 25, right? It's just like setting two functions equal to each other. So let's do this. I'm going to do my y1, and I'm going to call that 25. And my that's 25. And my y2, I'm going to call that 5x plus 3 sine x. Okay, plus 3 sine x. All right. Then I'm going to find the intersection of these. Everyone good with that? And that x value of the intersection will be where these two functions intersect. Okay, how do you do this? Second, calc, intersect. Didn't work. You have to zoom out. Okay, so I'm going to zoom out because I can't, that y equals 25 isn't here. So I'm going to zoom out. Do I have to hit enter? Okay. Okay, this is a little bit better. I see my y equals 25, and then this must be my y equals 5t plus 3 sine t. I'm going to find an intersection there. So that would just be second, calc, intersect. Okay, go to the left of the curve, hit enter. Go to the right of the curve, hit enter. Someone told me in second period I don't have to do left and right when I'm doing intersection. Yeah, it intersects once. Or they said if it intersects twice, as long as I get closer to it, I can still do it. So what I get is time is equal to 5.446. Okay, you guys have that? Okay, I need to go edit this video and take my age out. Okay, so time is 5.446. Well, that's great. Actually, let me put some dots here because we're not allowed to round that. What I want to do is take this number and plug it into all these t's. Okay, and you can do that, but I'm going to suggest an easier way. Everyone good with you could totally do that, right? And that would be your answer. Okay, so I'm gonna get this with you guys, see if this makes sense. Don't I really, all I want to do is take the derivative of this and plug in that t? right? And right here, isn't this just the derivative of this, but plug in that t, right? Okay, so I'm going to do a math 8. Is everybody good with that? What I'm going to do is I'm going to do, for this one, I'm going to do a math 8, and I'm going to plug in t equals 5.44, whatever. Okay, for this one, I'm going to do a math 8, and I'm going to do t equals 5.44, whatever. And isn't that going to give me the same answer? Okay, so it's a lot easier on you if you do it that way. But what you do have to be able to do is be able to store. I lost my little rabbit. Okay, I need to store this thing. So I've got this x-intersection as 5.445. I'm going to go to my home screen, and I'm going to hit X stow, and then I'm going to call this, I'm going to go C for, is hit math 8. Wait, is that right? Yeah, math 8. And this will be a dx. And put the function here, that's going to be 5x plus 3 sine x. So 5x plus 3 sine x. Okay, and my number here, x equals what? X is going to be alpha c. Okay, hit enter, and my answer here is 7.008. So this answer here is going to be 7.008. And if you're unsure about what I did, just plug in the t here and see if you get 7.008. I haven't tried it, but it should be the same. Okay, and then let's go to the right side. I'm going to do a math 8 again. And it'll be a dx problem. Over here, I'm going to put 8 minus t, so parentheses, 8 minus t, close the parentheses, open the parentheses, 1 minus cosine x. Okay, there's a lot of parentheses going on here, I think. Okay, and my x is going to be c again, so I'm going to put alpha c, and then pray. You guys give me a check on this. Did you get negative? Okay, negative 2.228. So this right here will be negative 2.228. And there, right there, is my velocity vector. Okay, so that one was kind of a fun problem to do together. All right.